How you doing? Thank you for tuning in to this here video presentation by Mr. Larry Whittington, or as he want to be known, Mr. Whit. Mr. Whittington's know all about mathematics, and that is why he founded the Fort Bend Tutorings. Today we're going to learn about word problems. Not the kind where you curse people out, but the mathematical kinds. The kind I don't be understanding at all. Alright, get your ink pen and your pencil ready. Take notes, because you finna learn from Mr. Whit.
Hello ladies and gentlemen, this is Mr. Whit with Fort Bend Tutoring, and today's tutorial is going to be about inverse variation. That is correct, inverse variation, and this is going to be part 2 of our variation series. And welcome, welcome aboard. When we are dealing with inverse variation, you'll see the equations written in this format. For instance, you'll have y equals k, which is a constant of variation, divided by x to a certain power. So let's talk a little bit about this k value. The constant of variation. It's also called the constant of proportionality. And throughout your problems, many of them will ask you for this specific value. That's right, the constant of proportionality, or they may call it the constant of variation. So keep that in mind as we move through our problems. Inverse variation has many different forms, but one of the most common forms is the form of y equals k divided by x to the first power. In that case, your graph of that inverse variation function may look like the function in red, or it may look like the function in black. All right, it all depends on your constant of variation and the power of the variable x. For instance, if your power of x is to the second power, you'll end up with a graph like you see here in black. Or it could look like the one in red, depending on the value of k, that constant of proportionality, the constant of variation. See how important that is? All right, let's go ahead and look at some problems. So here we have problem number 1. And in problem 1, it says if y is proportional to the inverse of x and y equals negative 1/2 when x equals 6, they want us to find the constant of variation, that value of k I told you to keep up with. And they also want you to solve for y when x equals 12. So in order to make that happen, we will first have our setup of our variation equation. All right, and it's going to look like this. We'll say that y equals k over x. All right, so y is proportional to the inverse of x is the same thing as y equals k divided by x. So I'm using that format from my first page in the video. Now notice they've given us information about this equation. They've let us know that when y equals negative 1/2, that x equals 6. So plugging in our given information, we know that when y is negative 1/2, that x will equal 6. So I've just substituted into our setup for the variation equation, and now I'll have the opportunity to solve for k. And I can do this by multiplying both sides by 6. So by multiplying both sides by 6, I'll have 6 times negative 1/2 equals 6 times k divided by 6. Simplifying this, I know that 2 will go into 6 3 times, and then 3 times negative 1 gives me negative 3. On the right side, our 6's, you already knew it, they'll cancel out. So you'll go ahead and bring down your variable k, and negative 3. Negative 3, that is our constant of variation. That is the answer to part A. Yeah, that's the answer to part A. So when we have an answer at FBT, we go ahead and red box it. That's right. You want to protect your answer at all times. You want to be a guardian of the correct answer because we don't want anybody messing with it. Nobody. So let's go ahead and put a red box around this. That's right. Red boxing it. Just like that. So your box should look better than mine because you know you've had way more practice at making boxes than I have. And in part B, remember, we're asked to find y when x equals 12. Now that I know that my value of k, that constant of variation, equals to negative 3, I can go ahead and write what is called your variation equation. Your variation equation can be written after you find out what that constant of variation is. So I can now write my variation equation as y equals negative 3 divided by x. And this is my variation equation, my inverse variation equation for problem number 1. And using this equation, I can go ahead and solve for part B, where they're asking me to find y when x equals 12. And all you have to do is substitute the value of x with the number 12 and simplify. It is that simple. Are you with me? Are you here with me right now? I mean, not physically, because obviously I'm I'm by myself. But if you were here, do you see what I'm talking about? Or you don't even need to be here. Let me rephrase that. Let's just say that if you were, you understand, okay? You understand. I don't even know why I was going through all of that. Let me just plug in this value of x and simplify the problem. We have y equals -3 divided by 12. Yeah, let's divide by 12. Simplifying this value, we end up with y equals -1/4. Oh, yes, that's right. Y equals -1/4. We're done. Except, don't forget that red box. Do not forget the red box. The red box is important. It will protect you in your time of need. That was the end of problem number 1, ladies and gentlemen. That was number 1. And now we're going to move on. Yeah, we're going to move on because I have more problems for you to check out with me, Mr. Witt. In problem number 2, it says, suppose A is inversely proportional to B, and A is -1 when B is 2. A, they want us to find the constant of proportionality, aka the constant of variation. B, they want us to write the law of variation, which is the same thing as your variation equation. You write your variation equation once you find out what your constant of variation is. And then finally, they want us to find A when B equals 5/4. I'm excited. Let's set this up. So we have A being inversely proportional to B. Notice how the variables may change depending on the problem. It's not going to always be X and Y, all right? So be aware of that. So what we want to do in order to find out our constant of variation, that K value, we'll be replacing A with -1 and our variable B with the number 2. So A is -1 and B is 2, just like that. And now to solve for K, yeah. You already know. I'm going to multiply both sides by 2. You already know this. I don't even know why you're testing me. All right. I'm thinking maybe you're a spy. Checking in to see if I'm teaching people correctly. Well, all right, spy. Yeah, I'll take your challenge. Yeah, I'll take you on. Okay. So anyway, simplifying, I have 2 times -1. That's going to give me -2. I have -2, which equals K. That's our constant of proportionality. This is our constant of variation. And I'm red boxing it. And you can't stop me. I mean, you got a stop button there, but what you going to do? No, you're not going to push that stop button. Not today, because we're doing inverse variation. All right, so here we go. Part B says to write the law of variation. In order to write the law of variation, all you have to do is replace your value of K in your setup. So we're going to write our variation equation as A equals -2 divided by B. Oh, that is an ugly B. I can do better. I'm going to fix it. But that's really not that much better. No. Yes. We'll keep that B. Okay. All right, that's a better B. All right, it's a better B. It doesn't suck as much as the other one, but it still sucks. I know. All right, so we're going to be plugging in 5/4 for B and solving for A in order to complete part C. Yeah. Oh, what did you say? We need a red box for our answer for part B. You're absolutely right. Let's go ahead and red box that thing. There it is. Red boxing it. Just like that, ladies and gentlemen. Just like that. So in order to solve for C, we're going to be doing some substitution and simplification. All right, let's make that happen. So here we have, let's go ahead and make some room. There you go. We have A equals -2 divided by 5/4. All right. Now remember, a fraction is division. So we can rewrite this as -2 over 1 divided by 5/4. And since I know that when dividing fractions, I need to multiply by the reciprocal of the second fraction, I'll do just that. I'll end up rewriting this as -2 over 1 times 4/5 and then multiplying straight across. So when I multiply straight across, I end up with -8/5, and that's it. That's the answer. I'm going to red box this. Red boxing it. And that's part C. So once again, In our original problem, they asked us to find the constant of proportionality. We solved that. They then asked us to write the law of variation. We did that by plugging in our constant of variation into our setup to get our variation equation. Then they asked us to find A when B equals 5/4. And so we plugged in 5/4 for B and simplified it to get our answer. You did a great job. Okay, so that's problem 2. Let's move along. And so we're moving along. I'm sorry. Problem number 3. For problem 3, it says if M varies inversely as the square of P, and M equals 2/3 when P equals 6, A, find the constant of variation, and B, find M when P equals 8. Oh, they are not ready for us, obviously. We're about to slay, aka kill, this problem. Let's start by setting up our inverse variation. So we'll write this as M equals the constant of variation divided by P to the second power, because it said the square of P. Thus, I have P squared right here. This is my setup. It is. And I'll use this setup to solve for my variation equation by replacing M with 2/3 and P with 6. Oh, yeah. Let's do that. Let's make some room. Make some room. There you go. M is 2/3 when P is 6. So simplifying that 6 squared, I have 2/3 equals K over 36. Solving for K, I'll be multiplying both sides by 36. So I'll write this as 36 times 2/3 equals 36 times K over 36. All right. You don't like that 6 either? Okay, I'll fix it. No, that's ugly 6. No. Yes, that's a better 6. Okay, that's a better 6. Simplifying this, we know that 3 will go into 36 12 times. And then 12 times 2 gives me 24. And this is our constant of variation, ladies and gentlemen. That's right, K is 24. So that's part A. We know that our constant of variation is 24. Now we'll go ahead and write our variation equation. Now notice they didn't specifically ask us to write the variation equation. However, it's necessary to solve part B. And we'll have M equals 24 divided by P squared. And there is your variation equation. We'll use this to solve for part B. So since we now know that M is equivalent to 24 divided by P squared, they want us to find M when P equals 8. So let's do that. So we'll have M equals 24 divided by 8 squared. Because P is 8, right? So we plugged it in, and now make some room. Now we'll simplify this to get M equals 24 divided by 64. All right. So let me fix this too, because I already hear it. I already know some of you will be like, hey, Mr. Witt, what's up with that 82 in the denominator? No, it's not an 82. It's 8 squared. Okay. It's 8 squared. Remember, we were plugging it in. Okay, we plugged it in. All right, now you want to simplify this. The 24 and the 64 can both be reduced by 8. So let's do it. So we'll end up with M equals, simplifying both of these numbers by 8. Simplify it. Go ahead, simplify it. There you go. We're going to end up with 3/8. And that's it. Okay, so now let's red box this. The answer is 3/8. It's 3/8. It's done. That was problem number 3. Now we're ready to move on. Okay, are you ready? Because I'm ready. I'm ready to move on. Let's move on. All right. Problem number 4. We have a table. It says in the accompanying table, y varies inversely with x. So if I were to show my setup as an algebraic equation, I would have y equals k divided by x. Because y varies inversely with x. That's what that means. See that? That's my equation there. So let's take a gander. Let's take a look at our table. We know that when we plug in 1, we get 6. We know that when we plug in 2, we get 3, and so forth and so on. Now, some of you may be able to determine what your constant of variation is just by looking at the table. No, I'm not doing that though. No, not me. I'm sorry. I don't know what you're looking at because no, I can't figure that out. I'm going to go ahead and actually use the values from the table. All you need is one set. That means one X and its corresponding Y value. So let's go ahead and use 2 and 3. Okay, 2 and 3, that's that second column right there. Let's use that. So we know that when X is 2, that Y is 3. So let's go ahead and rewrite this. So we'll have 3 equals K divided by 2, just like that. All right. And then in order to solve for K, we just need to multiply both sides by 2. Okay, let's do that. We'll have 2 times 3 equals 2 times K over 2. Like so. We know that 2 times 3 is always 6. Thank you. And the 2's, they cancel out. So your constant of variation is 6. That's exactly what it is. I'm red boxing this. All right. So now we have A answered. We have our constant of variation. And for part B, they want us to write the equation showing that Y varies inversely with X. In other words, find the variation equation. So in order to write that, we'll have Y equals 6 divided by X. And this is our variation equation. Red boxing it. Now that we have our variation equation, it will make completing the table that much easier. All right. So for instance, if I plug in 12 for X and I solve for Y using our variation equation, we'll end up with a result of 1/2. Plugging in 15 for X, we'll end up with a result that is 2/5. Plugging in 18 for X, we'll end up with 1/3. For our next entry, they're asking what value of X will give you a result of 1/4. Well, that'll be 24. In order to get a result of 1/10, you'll need to have a value of X that's 60. Now, let's say that you didn't know that. If you wanted to solve, let's say for that last entry, we know that our value of Y is 1/10, and we need to solve for X. So because you have a fraction set equal to a fraction, you can cross multiply since this is a proportion now. So cross multiplying here, I'll have X times 1 is X and 10 times 6 is 60. And that's how we end up with that result in our table there. Okay, so there you go. The table is helpless once you have your variation equation, because you can plug in your given values of X and solve for Y, and you can do the opposite. When they give you a value of Y, you can plug that in and solve for X. And that's problem number 4. Let's move along. All right. For problem number 5, it says the quantity B varies inversely as the square of C. What happens to the value of B if C is tripled? So for part A, they want us to write the law of variation, and then B, they want to know what happens to B if C is tripled. So to begin with part A, we have B equals K divided by C squared. All right, just like that. This is our law of variation, and this will do as our variation equation, because if you notice, they did not give us a concrete example so that we could actually solve for our constant of variation. All right, so this is going to be the answer for part A in a red box, just like that. Okay, now they want to know what happens to the value of B if C is tripled. So let's see what happens. If we were to take our value of C and triple it, it would look like this. B equals K divided by 3C squared. All right. So notice that I'm replacing C with 3C because the question is asking us what would happen to B if C is tripled. So replace your original C in your law of variation with 3C. And now let's simplify this. You'll next have B equals K over 9C squared. So when you compare our equation, this K over 9C squared with the original K divided by C squared, this can be shown to be the product of 1/9 and our original K over C squared. So what that means is that our original value of B will now be 1/9 of its original value. Exactly. That's what happens. That by using 3 times the value of C, your end result for B will be 1/9 of its original value. So that's what happens to B if C is tripled. You'll end up with 1/9 of the original value. And that's it. All right, so you can write it just like that. You can say that B is 1/9 of its original value, and that will be an answer to part B. And problem number 5. That's right. I'm going to red box it, even though it's already in red. Okay, there you go. Boxing it. Red boxing it. On to problem number 6. Okay, for problem number 6, it says the time required to complete a job varies inversely as the number of people working on the job. It takes 8 people 12 days to do a job. Part A asks, how many days will it take if 15 people work on the job? And then part B says if the contractor wants to complete the job in 8 days, how many people should work on the job? All right, so let's go ahead and start with our setup. From our original prompt, the setup would look just like this. I'm going to use T for time, and I'm going to write our setup as T equals K divided by P, which is going to be the number of people that we need to complete the job. So taking into account our given information, we can replace T with 12 and P with 8 because in our problem it says it takes 8 people 12 days to do a job. So let's go ahead and solve for our constant of variation. So I'll go ahead and say 12 equals K divided by 8. All right, just like that. Now let's go ahead and solve for our constant of variation by multiplying both sides of the equation by 8. So I have 8 times 12 equals 8 times K divided by 8. All right. From here, we'll be able to multiply. 8 times 12 is 96. And on the right side, your 8s will cancel out. So this is your constant of variation. Your constant of variation is 96. And we'll definitely keep that in mind. But we need to use this information to find our variation equation and solve for part A. So remember, K is 96. So I'll rewrite the equation as T equals 96 divided by P, just like that. So for part A, how many days will it take if 15 people work on the job? Let's go ahead and replace that P with 15. So by simplifying the 96 and the 15 by 3, we'll end up with 32 fifths. And if I were to write this as a mixed number, I would say that I have 6 2/5 days that are going to be needed, all right, to complete the job. And that's it. I'm going to red box it. Red boxing it. All right. And of course, you can give your answer as a decimal if they ask you for that. But it all depends on the text, the author, your teacher, or you, if you're given that free will to do so. All right. So there you go. In that case, it would be 6 4/10. All right. 6 4/10. 6 4/10 days. There you go. All right. So that's how long it would take. Now let's check out part B. All right, and for part B, we already have our variation equation. It says if the contractor wants to complete the job in 8 days, how many people should work on the job? So we'll replace our time, which is in days, with the number 8 because we want to complete this job in 8 days. And if I set this up as a proportion by placing 8 over 1 and writing this as a fraction set equal to another fraction, what we can do is we can cross multiply. All right. So by cross multiplying, I can rewrite this as 8p equals 96. And then dividing both sides of the equation by 8, we'll end up with a result of p equals 12 people. That's right. You want to finish that job in 8 days, huh, contractor? Well, you better have 12 people ready to help out. Red boxing it. Red boxing it. And that does it for our video for inverse variation. I hope you enjoyed it because I sure did. So as always, please rate, comment, and subscribe. Once again, this is Mr. Witt with Fort Bend Tutoring. And if you're able, please donate as that helps us bring you more free math tutorials from Fort Bend Tutoring. Peace.
We're going to be learning about such things as linear, quadratics, system of equations, tables, mixtures, work, oh Lord, distance, interest, of which I don't have much, investment. This is my favorite one. I'm going to name my grandbaby consecutive integers, algebraic translations, and percents. I understand a little bit about percents. I know that 50% off is pretty good.
So for number 1 here, we have the problem if y varies proportionally with x and y equals -1/4 when x equals to 8, A asks us to find the constant of variation, aka the constant of proportionality.